likeness. Yeah, pulling it out of cyberspace almost, but yeah. Show how to get this. Actually, I gotta be accurate with this. Let's say we want to show how to get this instead. So now instead of a double bond there, I now have a halogen sitting on it. So now the beginning steps are going to be exactly the same. PCC sets up a Grignard attack. Let me scroll down here again. So PCC sets up a Grignard attack. We attach the methyl there. But now what changes right here? Instead of elimination, what are we doing? Substitution. And he'll do just that. Now the PCC and Grignard, that's going to be a guarantee. There will be PCC and Grignard on your midterm because that's the most common type of mechanism Wagner likes to test you guys on, is knowing when to use PCC versus a Grignard and what order to do them in. Sometimes you may already start out with a ketone and you won't even need PCC for the reaction. But in this case, we have to make the ketone first and then attach the Grignard later on. So we can make some slight modifications like that. So instead of an E1 to cap off the reaction, we're doing an SN1. Or, theoretically speaking, we could end up with just this. Double bond there, but no methyl sitting there. So what step did I change there? I changed the Grignard step, right. So instead of using a Grignard, what are we using?
Hydride?
Yep, we're using a hydride. So we're not even going to be using the methyl bromide at all. And lithium aluminum hydride and sodium borohydride count as solvents you can use. So this guy would be here in this example, just be a troll. Just to troll you guys. But he can make slight modifications like that. And like the list goes on. There's several different ways he could modify this as far as switching up the steps throughout the reaction. But for the most part, you're going to see some PCC and Grignard being used because it's pretty much on every midterm. And it's for sure on the final. So good questions, you guys. Good questions. Anything else you guys have on this one? Not too bad, right? Nothing too terribly complex or complicated. Guys, you know how PCC works, and then know that a Grignard is going to come along later. And like I said, this guy right here, this structure, is huge for a question that comes up later on, and you guys are going to see it later on. You guys can probably already pick out which one it is just by looking at it, but...
Well, the thing that makes the Grignard is the addition of the magnesium.
Yep. What makes this guy a Grignard is the addition of this magnesium. Now we know that we could technically make a Grignard with any halogen and any alkali earth metal. We could use, the list goes on. We could technically use potassium. We can use the alkali metals in column 1. But now, for this class, Grignards will have MgBr together. So if you guys see magnesium bromide, that's going to be a Grignard. He's not going to make you memorize the other possible options. There's like hundreds of them. He just wants you guys to know how Grignards work, because the magnesium bromide, is it really that important to the reaction as a whole? When the reaction takes place, the magnesium bromide does what? What happens to it?
It breaks off.
Just falls off and floats off into solution,
Just use as a trick.
leaving us a carbanion, and that's the part that's actually important. But for the sake of this class, like I said, Grignards are going to be magnesium bromide molecules. So if you see bromine and magnesium together in the same page or reaction, you're making a Grignard somehow. Anything else on this guy? Anything else? Like, there's a lot in here that you guys got to take in for this one question, but I'm confident you guys have got this. You guys are going to be fine. But alrighty, so with that one in place, let us take a look at another problem child. Page 1.